Facebook spent 25 person years to create Threads. 25 to 50 engineers spent 7 months straight working on it. But what if I told you they could have made Threads with one engineer with under 10,000 lines of code, at least 30 times faster and cheaper? If they were using Rama by Red Planet Labs, they could have. This new data backend platform just dropped last week, and I think it's one of the most important developments in software engineering in decades. The creator of Rama is the prior creator of Apache Storm and literally wrote the book on big data. His name is Nathan Mars, and I'm proud to say I was one of the first investors back at Initialized. When I first met him, I realized if Rama had existed in 2008, my startup Posterous wouldn't have died. And if you're watching, your startup might not die today because you got to see this video. Watch to the end to find out exactly how a brilliant new abstraction for data structures means you won't be burning runway to recreate the wheel of data again and again. Let's get into it. How programmers write software that works with data is still stuck in ideas created 40 years ago. But if we build it for modern systems with lots of disk, lots of RAM, lots of CPU, and knowing it's going to be in a cluster, and we do it with the right abstractions built right into the data system, you get something magical.
It's a totally new approach to building backend system. And what Rama does is it integrates and generalizes every aspect of what it takes to build a backend system at scale, and it enables you to build backend applications in 100x less code.
Most devs today use some mix of MySQL, Postgres, Oracle, MongoDB, Redis, Snowflake, and each of those systems is, from the ground up, a new system to store, index, and retrieve data. But with that is a whole new set of code and tools. We're literally repeating ourselves over and over again in that data stack. Each new data stack is a new code base, new set of servers, new DevOps needs, and more surface area for bugs.
And so what Rama does is it enables you to build applications in fundamentally different ways. Because it's such a general purpose system, you don't need to combine dozens of tools together. You can just use this one tool. And if we look at like one piece of Rama, to see like how is it possible, it could be so general purpose, able to do what all these databases can do combined. You can look at how Rama does indexing.
My favorite thing about incredible technical teams is they're able to back up these strong words with a real feat of strength. In Nathan's case, one of the key examples he shipped was a full server implementation of Mastodon, a Twitter-like social network, but one that actually scales now with his code to Twitter scale.
So we built a scalable clone of Mastodon, which is basically the same as Twitter when you compare it versus the consumer product. And the amount of cost it took Twitter to build their consumer product was about 1 million lines of code and 200 person years of time. The cost for us to build essentially the same thing on top of Rama was 10,000 lines of code and only 9 person months of time. So it's 100x less code, but actually more than 200x less person hours.
Rama allows developers to do this in a fraction of the time because the abstractions Nathan and the team created enable autoscaling and extreme expressiveness.
The main difference between what we built and the open source Mastodon is the fact that ours can scale. The open source Mastodon cannot scale anywhere near what we can. So like in our instance that we have live right now, mastodon.redplanetlabs.com, we're running it with 100 million bots posting 3,500 statuses per second and at an average fan out of 403, which is many orders of magnitude beyond what the open source Mastodon can possibly do. And we're less code than them. Our backend is at least 44% less code than theirs. So it's
less code to do the same thing as the holy grail of software, and that's why Rama is such a crazy leap forward. What Nathan has figured out is how to help software engineers do the most basic things they try to do everywhere else in their code, but haven't been able to do in how they use data systems today. Don't repeat yourself. DRY. Rama is DRY, dry, for how you store and retrieve data. The programming model isn't new, but the way it integrates the pieces together has never been done before.
What makes Rama so powerful is how much it integrates and generalizes each of these pieces. On the left are depots. These are distributed, durable, and replicated logs of data. If you're familiar with Apache Kafka, depots are very similar except integrated with the rest of Rama.
Depots are append-only replicated logs. They're the fastest way to stream data to disk.
Next are ETLs, extract, transform, load topologies. These consume data from depots in parallel to produce indexes, which we call partition states. Most of the time spent building Rama applications is spent programming ETLs, which are programmed with a pure Java API. Next are partition states, which we usually refer to as p-states. P-states are how data is indexed in Rama, and they're also durable and replicated. They serve the same purpose that databases do, but they're much, much more powerful. The last concept in Rama is queries.
When you think about scaling Twitter or Mastodon, this is where complex scaling operations that might happen at the app level can be brought down into the data layer and scaled automatically, like the denormalized fan-out of feeds for posts going to followers.
There are two forms of queries in Rama. The first is ad hoc queries that can retrieve or aggregate data from one partition of one p-state. These are called point queries. The second are query topologies, which are predefined queries that can look at any or all of your p-states and any or all of the partitions of your p-states.
Instead of trying to fit all your data inside these simple but ultimately too unstructured forms of tables, columns, and rows, or even JSON blobs, these concepts let you create data structures that really mirror the underlying information that you're trying to represent.
P-states do in Rama what databases do in traditional architectures, and you can understand p-states in contrast to databases. When you look at databases, they all have fixed indexing models, what they call data models. There's key value, document, column-oriented, graph, and so on. A better way to think about indexing is in terms of data structures. A data model is just a specific combination of data structures. Key value is just a map. A document data model is a map of maps, column-oriented is a map of sorted maps, and so on. Databases that support secondary indexing just materialize additional maps alongside the primary data structure. A database like Redis is a little more flexible, allowing your values to be sets or lists. But ultimately, all these databases and their underlying data models support a very small number of data structure combinations. We're talking about just a handful versus the infinite number that are possible. Building backends has always been like this, at least since I've been alive. So it can be hard to see this as a limitation. But this is like if in regular programming, you could only use a handful of data structure combinations and nothing else.
None of this is abstraction for abstraction's sake. When people conceived of SQL databases, they didn't have a sense that people in the future would have plentiful access to data centers where the dominant way to scale would not be bigger servers, but more servers. Rama is built for this reality, and this abstraction allows you to keep the data structures in one system instead of many.
But this is the reality of backend development from databases being so restrictive. If you can't fit a use case onto your database's data model, then you need to deploy another database with another data model. Deploying and maintaining multiple databases is expensive. If no database's data model fits your needs, then you might need to make your own database from scratch, which is extremely expensive and unfortunately not that uncommon. Rama's p-states are completely different. Every p-state you create can be whatever data structure combination you want, and you create as many p-states as you need to support all your use cases.
When Nathan says new databases, this isn't merely just partitioning data in yet new database clusters. Often in companies, you're using a whole new stack, MongoDB, Redis, and back when I was running systems for my startup, at some point I realized I was just doing a crude version of partitioning across new database-like runtimes. And if you're doing that, you lose the ability to join that data across systems to do useful things. And not only that, you're actually compounding the problems of scaling data systems. Just because you've moved a table or data to one microservice to a separate stack doesn't mean the problem is solved. It just means that you need to shard that data further later. And then you've got two problems, because you are tracking entire tech stacks contracts, support contacts, logins, auth, backup, and then all of those other things that are necessary when you add servers. All of this in a modern data stack is a waste.
Everything about Rama is inherently distributed and scalable. And so when you deploy a Rama cluster, you tell it how many partitions and how many workers to deploy it on. And then Rama has this great built-in monitoring, which basically tells you when it's going to need more resources. And then it's literally just a one-liner to terminal saying, okay, I want to increase this application currently running in a cluster. It's currently running with 20 workers. Let me increase that to 30. And so the one-liner, you press enter, it takes a couple minutes for Rama to execute the transition. And then that's it. That's all it takes.
So that's Rama in a nutshell. It truly is possible to change your abstraction and get a massive boost. At my startup, Posterous, we got stuck in MySQL scaling hell, and I never got out of it, and our startup suffered for it. Better software is possible, and it's here today.
So in terms of what's available right now, so number one thing is we've released a build of Rama that anyone can try out and use. It lets you build full Rama applications and run them within a simulated cluster environment. So that's, we've on our documentation that's available on our website. You can find the details on how to access that. And we're not going to hide behind the fact that Rama has a learning curve. It definitely has a learning curve, but the benefits are so extreme that it is well worth your time to learn it. And the best way to learn it is to start with the documentation. The documentation contains a 6-part tutorial that gently introduces the concepts and culminates in building a complete social network end-to-end in only 180 lines of code. And the rest of the documentation does deep dives on all the aspects of Rama. So come check it out at rentotlabs.com.
Link in the description right now to try Rama for yourself. The startup that you save might be your own. That's it for this week. Thanks for watching all the way to the end, and I'll see you next time.